Okay, so lecture 7 is going to be talking about the graphs of equations, and we're going to be looking at two different things. We're going to be looking at finding your x and y intercepts, and after we finish with our x and y intercepts, the next video we will talk about symmetry between different graphs. So, getting started here, we're going to focus on, I do that every single time, we are going to focus on finding your x and y intercepts. So, where are the x-intercepts? Well, on this graph here, my x-intercepts are all of these points that are here in blue. Okay, every single one of these points here is an example of an x-intercept. Okay, now these are going to be kind of arbitrary points, but let's say that I was super accurate here. This point is 2, 0. This point is 4, 0. This point looks like it is negative 2, 0. We can say this is negative 3, 0. And this point is negative 4, 0. So what do every single one of these points have in common? Well, they're all the x-intercepts, yes. But if I look at their xy points, they all have a 0 in the y spot. Okay? And that is true for every single x-intercept. For every x-intercept. For every x-intercept, your y value has to be 0. By definition, where something crosses the x-axis, the y value is 0. So for every x-intercept, the y value is 0. We only have one y-intercept on here, and that is because we're dealing with a function. Okay, if you remember the vertical line test, okay, you can only have one y value. This would not pass the vertical line test if it had two y-intercepts. Okay, but we can, say, hey, this is 0, 2. Okay, let's say that we had a completely different function and it crossed right here. That's another potential y-intercept. 0, 1. Say we had one down here, 0, negative 2. Okay, and I know that not all of those y-intercepts, they couldn't all be on the same function, but all of those potential y-intercepts, notice that they have a 0 in the x spot. So just like where every x-intercept, your y value has to be 0, okay? For every y-intercept, okay, your x value has to be 0. So, in summary, if we scroll on down to the next part of this, okay, finding intercepts from an equation. With your x-intercept, okay, the y value on every single one of those points is 0. So if I want to find an x-intercept, I need to, oh my goodness, I need to set my y equal to 0. And then I just solve. Okay? If I look at my y-intercept, I'm looking at my y-intercept. Remember that 0 was there for all of the x's. Okay? So if I want to find my y-intercept, I am going to set x equal to 0. Then solve. Okay? So this slide right here, and we will continue doing this. Anytime you're trying to find an x-intercept, set your y equal to 0. Anytime you're trying to find a y-intercept, set your x equal to 0. Okay? So let's just do some practice problems with this here. It says find the x and y intercepts for 3x minus 5y equals 15. I've already got this written on your notes, but it is a good practice to make sure that you guys separate these just so that you know which is which. Okay, so for my x-intercept, remember I want to set my y equal to 0. So I will have a 3x minus 5, and then instead of a y, I want to plug in a 0 in that spot, and that equals 15. So this is just a 3x, and then negative 5 times 0 is just 0, which equals 15. So really, negative 3 times 5, oops, that is bigger than I thought it was going to be. I really don't even need to write anything. Just 3x equals 15. Okay, divide both sides by 3, and I get that x equals 5. Now, that is not my final answer because remember your x-intercept is a point. Okay, so my x value of this point is 5, and then what is my y value? Remember, I set my y equal to 0. So 5, 0 is the x-intercept for this graph. Okay, next, you've got to find the y-intercept. Remember your y-intercept, you're going to set x equal to 0. So this equation is now 3, and then not an x. You would plug in a 0 for that x. Minus 5y equals 15. 3 times 0 is just 0, so we end up with a negative 5y equals 15. Don't forget that negative there with that 5. Okay, divide both sides by negative 5, and I get that y equals negative 3. Because if I divide by negative, positive divided by negative gives me negative. Okay, again, not my final answer. Our final answer is a point. We know that our y value is negative 3. What is our x? Remember, we set our x equal to 0. So the x-intercept for this equation up here is 5, 0, and the y-intercept is 0, negative 3. Okay, a couple more that I want to practice with you guys here. Okay, I've got find the x and y intercepts for y equals x squared minus 3. So again, I always just kind of make that little t-chart there. So x-intercept, I want to set y equal to 0. So this is 0 equals x squared minus 3. Now, usually when I would deal with something like this, I would tell you guys you want to factor if there's an x squared. Okay, but remember, you only have to factor if it's an x squared and an x. So if it were to look something like this, then yes, I would have to factor because there is an x squared and an x. But since it just has an x squared, I actually don't have to factor to solve this one. Okay, I could add 3 to both sides. When I do that, I get 3 equals x squared. Now I would have to get rid of that x squared, so I can take my square root. And then remember, our square root property says that when I do that, x squared equals something, there is a plus or a minus. And we're just going to leave that as square root of 3 because we can't simplify that. Okay? So, not my final answer though. 3, 0 would be an x-intercept, or sorry, square root of 3, 0. And then negative square root of 3, 0. So this has 2 x-intercepts. Okay? Next, we have our y-intercept. A lot of people don't want to show work on this. Still show your work. Okay? I'm going to plug in a 0 for my x when I'm trying to find the y-intercept. Minus 3. So y squared equals 0 squared. Or sorry, y equals 0 squared minus 3. Okay? Well, 0 squared, that's just 0. So we get y equals negative 3, which means that our y-intercept is 0 for my x, negative 3 for my y. Okay, let's run through one more example here real quick. Okay, we're going to go ahead and scroll down. Okay, and this one's going to be a little bit more complex. Okay, this is a circle. Okay, so I told you guys that you'd only have one y-intercept for a function. However, circles are not functions. Circles would not pass that vertical line test if we tried to do that. Okay, so this one we will have 2 x-intercepts, we will have 2 y-intercepts. All right, so let's go ahead and get this one solved here. X-intercept, I need to set my x value. X-intercept, I need to set my y value equal to 0. So we've got x squared plus 4x plus, instead of a y squared, I'll have a 0 squared. Minus 2 times, instead of a y, I'll have a 0. I plug in a 0 for all of those y's there. Okay, and then that equals 0. So I'm just left with x squared plus 4x equals 0. So I have an x squared and I have an x. I'm going to have to factor to solve this. Okay, now, there's no factoring by grouping, any of that factoring stuff that we do. All we have to do on this one is look at, hey, they both have an x in common. So I'll pull that x out. And I'm left with an x plus 4. Set each factor equal to 0. And I find that x equals 0 and x equals negative 4. So my x-intercepts are 0, 0. And they are also negative 4, 0. Okay. Y-intercept is going to be super, super similar. Okay. I'm going to go through here. It's not x squared. It's 0 squared now. Plus 4 times, not an x, because we're plugging in a 0 for our x's, plus y squared minus 2y equals 0. So all that is y squared minus 2y equals 0. Again, just pulling out the y that they both have in common. and I get y equals 0. Y minus 2 equals 0, which is just y equals 2. So my y-intercepts are 0, 0, and 0, 2. Okay. That 0, 0 would be a y-intercept and an x-intercept. That's why it's on there twice. But that's basically what you guys need to remember. Finding your x-intercepts, set your y to 0. Find your y-intercepts, set your x to 0.